All right. I want to welcome everyone, especially to the day three of 3 day long professional training on industrial machinery maintenance. Yes, it has been quite a very interesting experience for the past 2 days. And today the experience continues, and it's going to be a great and wonderful one in today's class. I want to say welcome to everyone who is in today's class and who has been a part of this training since inception. A very big welcome and congratulations to you for being with us thus far. Okay, thank you very much. I want to say, okay, welcome. Pardon me. So in today's class, we are going to be picking up from where we stopped. So like we did mention at the beginning of this training 2 days ago, that this training is sectionized into 4 parts that we are going to be covering: industrial electrical maintenance, mechanical maintenance, automation and control systems. And we are going to be looking at industrial hydraulic and pneumatic and machinery maintenance. So far, so good. We've been able to touch on some of those aspects. And in today's class, we'll try as much as possible. The other aspect that we have not really touched on, we are going to do justice to them. And I do always like to tell many of our trainees or those who we have trainings together like this, that learning is a continuum. Learning is not something that is static, or that because you've learned from somewhere, you just stop there and you think that is all. No, as far as maintenance is concerned, there's a whole lot to still learn from. So our class is like an eye opener, and for you to be able to groom yourself, for you to be able to get acquainted with some of those things that is relating to maintenance that you need to know as a maintenance engineer or as engineering personnel. Okay, so I expect that as we conclude or finish this class, that you go back and do more research on how you can improve your skills, your understanding, and how you can put to practice all that has been taught or all that you have learned in this training so far. Okay, so I encourage us to please embrace that kind of attitude. It helps as trainers, as trainees, as practitioners or professionals in the field of engineering or in the field of maintenance. It really helps us a whole lot, and it helps you to get better. Okay, like I did mention, today is going to be the last of the classes that we have, and tomorrow is going to be for us to attend to every of our assessment, because at the end of today's class, we are going to be releasing the assessments for you that we have covered so far, on everything that we have covered so far in this training. So we are going to be dropping the assessment link. So please try as much as possible to make sure that you attend to those assessments. Aside from it be a test of your knowledge or understanding of what has been taught in the course of this training, it's also a prerequisite or a requirement for you to be able to access a certification for this training. So it is very, very important. Take the assessment. Once you see the link, attempt them. You are not expected to pass everything. And trust me, everything that you will meet in the assessment, they are things that you have learned in the course of this training. So don't panic. It's not something difficult, but trust me, if you have been in class or you have watched the recorded videos of this training so far, yes, you will be able to attend to. Yes, thank you very much, Mr. Gilbert. Okay, so a quick one with the information relating to the certification for this course on the WhatsApp platform. I think we did that yesterday. So there is a form for everyone who is interested in the certificates. There's a form that we have dropped on the WhatsApp group. I think it was dropped this afternoon before the start of this class. So try as much as possible to fill that form. Try as much as possible to fill the form. It's a certificate request form, so that you'll be able to benefit from the discount offers that we have on the certification. Yes, so in previous trainings, some people actually didn't fill the form, and they did the training, they didn't fill the form for the certificate. So when all the discount offer has ended, they came back that they really needed the certificate, and we're expecting that we give them the what's it called, the discount rate or discount offer. Of course, it's not possible. So if you fill the certificate form and you have done the training, you've done the assessment and everything, by the time you come back, yes, it might be a way of considering you for any of the discount offers that we have on that certificate at that particular point in time when the training was conducted. So it is very important that you fill the certificate form. So it's a way of you following up or that yes, you are really interested in the certificate discourse. And maybe when the discount is offered and you come back, perhaps we may consider you for any of the discounts. Okay, so the special discount offer on this training so far is going to end on the 21st of May. It's going to end on the 21st of this month. So you want to do well, try as much as possible to tap into that discount, special discount offer that we have on this course. So after the 21st of this month, other discount offer is going to take effect. That is the second discount offer. Then we have the third. So they are going to take effect respectively as their due date or their end date approaches. Okay. So in today's class, our resource person is here with us, and like from where we stopped yesterday. So it's none other than many of us who are as he explains with his method of with his method of training, with his method of teaching. Yes, everyone who is a part of his class will actually be carried along. So you'll be hearing his voice in a brief moment from now. Okay, please, if you can hear my voice, yes, I saw it pop up. If you can hear my voice, just give me a thumbs up. If you can hear my voice, please give me a thumbs up. Okay, very much. Thank you very much. Thank you very much. Okay, so let's go straight to class. So at the end of this class, please, if you have your question, just note it down. We'll be giving ample opportunity to ask questions. Like I said, today is going to be we are going to be wrapping up everything regarding this training, the 3-day training in today's class. So please, I would love to have your contributions. I would love to have your your questions and the likes. Okay, so and if you're in a place whereby you cannot speak, just put your questions in in written form. We'll do the needful to to bring it up at the end of the class. Okay, so let's dive straight into today's class. Our resource person is here with us. Yes, Mr. James is here with us. So please, at the end of the class, reactions, your feedbacks, and everything, we are going to be taking it. So please, when we call on you, just do us the honors of responding to our call when we call on you to give us your feedback of the training and classes so far. Okay, so thank you very much, everyone. So the next voice you'll be hearing with that of our resource person, Mr. James Fanny. Yes, we have a lot to cover in today's class. So please, let's give him our undivided attention. And trust me, yes, we are going to have a wonderful and pleasant learning experience. Okay, so Mr. James, over to you.
I'm trying to bring my page on board now. Can you see my screen? Can we see my screen now?
Yes.
Yes, sir.
Thank you so much. I have to use a different device entirely. I don't know what is it with my device. All right, Mr. Moderator, we are on. Thank you so much. Mr. Moderator? Mr. Moderator? Okay. Pardon me. So for the good 2 days now, we've been discussing about this. That's industrial machinery maintenance. And this night, I want us to be very fast because we have so many things to cover. So I want to start with hydraulic and pneumatic system. So I want to start with the hydraulic and pneumatic system. We have really discussed, almost the nook and cranny of things that we need to know as basics for machinery maintenance. We have also discussed those ones that affect the mechanical. Like in our second class, we discussed a lot about that. I want us to start from hydraulic, and then we talk about some of the mechanical also, that's mechanical machinery maintenance, and then we dive into some part of the electrical, so that it will be an all-rounder kind of training, because the plan is to touch all these areas for different kind of people that we have from different fields who are actually registered for this training. So when we talk about hydraulic and pneumatic systems, because many of us might have, in one way or the other, we have actually either interacted with some of these machines, operate them, or we have them, in our industrial environments. So they are actually industrial machinery and equipment. And, we have hydraulic system that has to do with what usage of oil, okay, to power some of this machinery. And we have some that are using what air as the power, which is actually what pneumatic. So let's briefly look at the components of hydraulic system. In hydraulic system, you can have motors. We have the cylinder, okay, because like I told you, it's making use of what oil. So you have the cylinder, you have the valves. The valves is like an opening gate. Is used to actually regulate the pressure. Okay, so you can use valves to regulate the pressure. We have the filters. I explained some of these in the second class, talking about your oil shouldn't be contaminated. So we have filters there that can actually filter some of the contamination. And in most cases, when you're performing your maintenance, you have to check on the filters also to know if there are some clogging already what's happening there. Some, it's just like something refrain or holding back debt for over time. So it's like your gutter. If you fail to actually remove those blockages in your gutter or in your drainage, definitely you will see that water will not be able to flow. So the same thing with filters. So if you have contaminations or some dirt that are already accumulated on it, sometimes you have to bring it out and just clean it, and sometimes you have to change the filter completely, depending on the system that you are dealing with. So pardon me, I'm using a different device. My device is so. We also have reservoirs. This reservoir is to store the oil that you are using. Okay, the oil that you're actually using, you use reservoir to actually store it. I hope we can still see my screen. Can we still see my screen?
Yeah, your screen is showing. It's not showing the material.
Okay.
Perhaps you should stop presenting and represent, I guess.
Okay. I really want to share the material, even though I can actually move without sharing the material, but I want you to be following exactly the way I'm. Okay. Okay, we are good now. Thank you so much. I think my device is back. Thank you so much. Yes. So you can see it now, right? Can we see my screen?
Yes, now? You can go ahead, sir. Your majority.
Yes, we can see it. Yes. We can see it, sir.
Thank you so much. So we have thank you so much. So we have the hydraulic components. We have pumps, we have motors, we have cylinders, we have valves, we have filters, we have reservoirs, okay, for the storage of this oil. And what is the work principle, the principles that hydraulic system actually work on? It works on Pascal's law. How many of us still remember Pascal's law? How many of us in the house, the engineering, the science-oriented people among us, in fact, all of us, I expect us to actually be science-oriented. How many of us still remember Pascal's law? How many of us? Anybody? There's nobody in the house that remember Pascal law.
It's been a long time.
It's been a long time.
I think pressure is talking about over here.
Hey, okay. Can you hear me?
Pascal's law is actually the law that is applicable to, when you are talking about fluid that is actually enclosed. It governs the transmission of power, governs the transmission of pressure within that particular container. So, and then when you are talking about the formula is what you actually brought up. But in my own training, it's not the formula I actually want to treat. Okay, it's not the formula I want to treat. I want to actually treat the application. So, as you have rightly said, that the pressure itself is equals to force over area. That's the pressure. Okay, but Pascal's law and the application of how the pressure transmission is in an enclosed container. Don't forget that we are talking about hydraulic system, and in hydraulic system you have the oil actually in an enclosed system. So the pressure, the way the pressure is actually distributed within that container is what is governed by Pascal's law. I don't want us to be going into those theory, but just the application. So the principle also relies on hydraulic pressure, the flow rates. So the flow rates, like I discussed about valve. Valve can actually be used to actually govern the flow rates, okay, to control the flow of this oil that we use in hydraulic system. So what is the application of hydraulic system? Heavy machinery. Okay, heavy machinery, I mentioned it in the second class, they make use of hydraulic. Construction equipment, they make use of hydraulic. We have manufacturing machinery, they make use of hydraulic. Now, the aspect that concerns us, because you can see I'm not really focusing on all that, is the maintenance of hydraulic system. Now, what are the maintenance which we are actually learning in this course? Those are the places where I need to actually lay emphasis. So there should be regular check, on the fluid levels. So you have to conduct a regular check on the fluid level. So always check, and also check the oil condition. It is very important. Whenever you are also performing your maintenance, you should know when to change the filter. In most cases, oil filter, when you are performing your preventive maintenance, okay, it is good to actually replace the oil filters, and also use the recommended oil. The recommended oil should actually be made use of. So you should use the recommended oil. In our second class, I made mention of sometimes you have to go through the manufacturer's prescriptions. Even there are some manufacturers of equipment that they also produce the oil that equipment can actually use. So if there is a particular oil that it has to use, try not to think that you can outsmart the manufacturer. Use the oil that is prescribed for the hydraulic system. One of the issues that you may have with hydraulic system is leakage. Okay, leakages. When you see that the pressure is not coming, so if you go and check, there might be leakage somewhere, because like we explained that the oil is actually the one producing the pressure. Is the pressure of that oil that we actually transmitting into the power that the equipment is using. So you have to inspect for leaks, okay, if there are leakages and all that. Whenever there is a problem with hydraulic system and you have to troubleshoot, most of the issues that you can have is either you have low pressure, or you have high pressure, or you have leaks, okay, or you have clogged filters. I've explained that. So it's just like packing dirt, okay, dirty or things that could contaminate the oil, dust and all that. They will clog on the filters. And what is the usage of filters? Filters means that what the oil, that's where the oil is actually passing through. We put the filter there so that what oil will only pure and clean oil will be able to flow into the system, and anything that has to do with what dirt or anything that is not clean or contamination that is in the oil can actually be retracted by the filter. So you can imagine if the filter is doing this job over and over again, and for a long time, just leave the filter there and it's not really being replaced, or in some system where you have to clean. But for the oil, it's good that when you are performing the maintenance, just change it because of the clogging that may actually happen there. So that's briefly about hydraulic. Pneumatic system. In pneumatic system, we also have components. We have compressors, okay. We have air tanks. We have valves. Also, I've explained the valve is also doing the same work that we explained it to be doing when I was discussing about hydraulic system. We have cylinders, just as we have in hydraulic also, okay. We have motors, that's the drive itself, and then we have filters. So we also have air filters. Yes, there are air filters because there's also some dust, okay, that that may actually contaminate, the air that we are making use of. So we need to actually filter it. So we also make use of filter. The principles. These also work on the principle of Boyle's law. Do we remember Boyle's law?
Yes, sir.
Okay, can you help with that?
Boyle's law says that in a system, provided that temperature and other physical properties remain constant, the pressure provided is directly inversely proportional.
Each mass of gas is inversely proportional to its pressure.
To the volume.
You only have a V1 C1 equal to V2 P2. Okay, so meaning that if you look at that, the inverse proportionality actually shows that the higher the pressure, the lower the volume, or the higher the volume, the lower the pressure. So that's just the principle it actually works on. Okay, it is very important. See, that's actually the problem with our education system. It's not anybody's fault, okay, that we struggle with it. But trust me, it will make more sense when you work with most of these equipment. You will appreciate the principle that we learn back there in school. All those theory, they're actually meant for the application, and you can use them to troubleshoot. So when you know the principle that is working with, you can easily troubleshoot. Like when I was mentioning about Pascal's, okay, the Pascal's law. If you understand Pascal's law, okay, then you will know when there is problem with pressure within an enclosed fluid. Okay, when there is problem with pressure, okay, you'll be able to actually troubleshoot. I don't want us to turn it to theory class, stating Boyle's law and proving and all that. So I could have actually brought it out for us to discuss. But the principle is also based on air pressure, the flow rates, like I explained about valve. Applications. Manufacturing machinery make use of pneumatic. We have material handling equipment making use of pneumatic, and we have pneumatic tools. These are systems that are making use of air as their source of power. Okay. What is the regular maintenance that you do on pneumatic system? Regularly check air pressure and flow rates. It's very important. Replace filters and lubricants, when needed. So just as I mentioned when I was talking about the hydraulic system, you need to also change or replace the filter of the air filter, okay, when necessary. Inspect for leaks. One of the greatest issues that you can also have is the leak, okay. Just like you are trying to gauge your tire of your car, you gauge it now before you move 3 hours or 4 hours. You see that the tire has gone down. So there must be leakage somewhere. Okay, you might not actually be able to diagnose, or you are not really. It's not maybe a loud one like that, but the tire is actually leaking somewhere. So in the pneumatic system also, you watch out for leakages. Okay. Inspect for leaks. How do you carry out troubleshooting? low air pressure, just as we have in hydraulic also, there can be low pressure, there can be what? High pressure, okay? Within the system, within the hydraulic system or within the what? Pneumatic what? System. There can be leaks. These are the major what? Issues that you have with the system. So when you want to troubleshoot a pneumatic system, what you are looking for in your mind is that with the way the equipment is behaving, is this due to what? High pressure? Troubleshoot with the mindset that maybe it could be low pressure. You troubleshoot with the mindset that it could be that what is leaking somewhere, and you troubleshoot with the mindset that what the filter could have what clogged somewhere, that might be clogging on the filter. So if you follow this troubleshooting, I'm assuring you we still will release the material. You see how, you know, we actually what put everything in details there. So if you have this form, you know, you have this direction about the troubleshooting, it will not be difficult for you to resolve any issues relating to pneumatic or hydraulic. So let's bring the common issues to out together now. The leaks that I explained in hydraulic, when you're talking about leaks, we are talking about what? The fluid what leaks. When the fluid that you make use of, the oil, when it's actually what leaking somewhere. So that would actually what be the problem. So you look for leaks in what? The oil. When it comes to pneumatic, you look for air leaks. When we talk about the clogged filters, the fluid what filters could actually work clog, or the air filters, as I've explained that. You should also check for worn or damaged what components. Okay, maybe the cylinders, hydraulic cylinders, or the pneumatic what cylinders. They could also be what worn out, or they could be what damaged. Your valves should be what inspected. There will also be problem if you make use of what incorrect fluid. I've explained that, and I cannot really, you know, I can't say that, you know, more than what enough. You have to use, you know, the prescribed fluid, you know, for the system. It is very important. The air pressure should be monitored also. The hydraulic what pressure should be what? Hydraulic fluid pressure should be monitored, and the air pressure should also be what? Monitored. Many people don't know that. You know, people just take their car to all these vulcanizers. They say they should what? Actually what? Gauge for them. And when they gauge your car, you just move. They could, the pressure within your car tire can be too much, and that will be dangerous for you to drive with. And that is why if you see a very good one among all those vulcanizer, they will show you, they will bring out the pressure gauge. In fact, you should ask for it. There are many people that even have it in their car. It is not too much. It does not really cost that much for you to actually have. So before you actually conclude that, oh, the pressure of this tire has gone down, you need to actually plug it in and check the pressure. And you work with the prescribed pressure of that tire. The manufacturer of your car, or the manufacturer of that of that tire, if you make your research where the pressure is actually what indicated. So you should know, you should be able to actually pump your tire with the accurate needed pressure, not high pressure, not low pressure, because both of them are actually dangerous. So what many people care for is that, oh, there is low pressure in their tire, and they want to pump it. Many people don't really mind or think about that, oh, what about the high pressure? What are the tools and equipment that you may need in the maintenance of this? Your hydraulic pressure testers, okay? Just like I make mention of, you know, you need to measure the pressure. So there are pressure testers, okay, that will show you that, oh, this is the pressure that is in there, and you'll be able to know if that is the prescribed pressure for the system that you're working on, the machinery, the machine that you're working with. Pneumatic pressure testers, okay, for measuring air pressure also, like the one I mentioned about tire. Yes, they are there for you to use, so that you'll be sure that you're not working with or you are not driving with in the case of car, I'm using as an example, with too much of pressure or low pressure. Okay, we use flow meters, we use multimeters in the system. the safety remains the same. Like we have mentioned what in our second class, the safety are always what almost the same. Your PPE, your logout, tag out before you perform maintenance on it. If it's happening in a confined space, okay, confined space entry happens to be, you know, if there's a restriction to the entrance of where you want to go and walk. Let's say, you know, just one way in. There are some places like that, one way in, one way out. That's confined space. And only one person can go in, can bodily enter the place. And you can use only limited time. Maybe if there are anybody here that has worked in a confined space here, you can share your experience at the end of the class. So only one person will be able to actually what? Go in, go out. In fact, in some confined space work, there are people that when they are going in like that, they will have to tie, you know, something like chain to their leg. Something like a, you know, rope or chain like that would be around their what? Ankle, such that somebody will be outside that will intermittently be checking on them by dragging the chain. So if everything is all right, you kick your leg. The person that is inside, that is walking inside, we have to kick his leg, drag the chain back, which actually shows that what? Everything is all right. If not, if they drag the chain that there's no response, they have to drag him out because it's a confined space. Sometimes some people go in with what? Additional oxygen to breathe in. Sometimes they have to do air testing there to know if they are performing welding work there, if there could be, you know, fire outbreak or anything like that. So when you are working, if the pneumatic system that you want to go and maintain is in a confined space, that's what we are talking about. You have to take an extraordinarily, you know, authorization when it comes to what? Safety. Sometimes even the first aiders will be on guard, and you know everybody will be there because anything could actually go wrong. So we say follow the procedures for entering confined spaces when working with hydraulic and pneumatic system. It is very important. So those are the safety precautions that you actually have to take when working with hydraulic system and pneumatic system. So what are the best practices recommended for this? Follow the manufacturer's instructions. I've said that over and over again, so I don't need to emphasize on that. Follow the manufacturer's instruction. Okay? Use proper tools to perform your maintenance. Don't try to force tools. Don't try to force tools. Don't say you want to improvise and a bolt that is supposed to actually lose with 13 spanner. Sometimes you see most of those things actually happen. You are using a wrong spanner or you are using a wrong tool on a particular bolt or on a particular joint for a long time. So what will you see? You will see that it will worn out. Even when you bring the correct tool, you won't be able to actually open it again. It's sometimes human's fault. Most of these things are human faults because you are using a wrong tool to actually perform your maintenance or to do your work or installation. So use proper tools, okay? The personnel that will actually carry out the maintenance must be a trained personnel, somebody that is trained to do it. We shouldn't just push people to go and say, oh, you can do it. It's a very simple thing, okay? Or something that you just go and watch the video and then you want to go and try it. No, you have to be trained on it. It's very important. The procedures that should be followed should be documented so that it will help every personnel that wants to work on it. Okay, what is the procedures? Do you have to open this place before you lose this place? Do you have to close that place before you open this place? Those are the procedures. It should be documented. It shouldn't be something that you believe that the person performing the maintenance should actually know. No, there should be documentation about it. Like in our last class, my friend here that shared his experience about how they take, Lotto at their place of work. So you can see that is proper documentation. Everybody knows. Everybody already have a Lotto tag. They can take group Lotto for them to actually go and perform maintenance. Like more than one department performing maintenance on a particular system at the same time. So these things are documented. So anything about maintenance for any machinery in a company should be documented. If you are working in a company where all of you just know the maintenance of the particular machine by heart, just know that it is a wrong practice. It has to be documented. What you need to do when you are maintaining a particular system or a particular machinery, you have to have what? Documented procedure to follow. Because that's only what could actually nail you, that can crucify you, or at the same time free you whenever you have performed your maintenance. Did you actually do all these things? Should you check the oil level? Must you change the oil? Must you change the filter? Must you do this and that? All those things should be documented. It shouldn't be assumed that you know. And we have some regulations and standards here. I just put it there for you to actually see that there are standards, there are regulations that actually manage all these things across factory. So I've talked about hydraulic system troubleshooting.
Also, should I open a video?
Opeyemi, please. Kindly mute. Thank you. So we talked about the pressure, okay? The matrix system troubleshooting, I've discussed it. Everything I explained, I try to, kind of elaborate them the more. That's what you are seeing that I'm actually sliding. So just to elaborate more on it so that you can have my explanation documented. So, all right. So let's talk about electrical system maintenance. Electrical system maintenance. So what do we do in the course of maintaining electrical system? The regular maintenance, which is the known one, the scheduled one, the popular one that I've been mentioning that is very important, that's the preventive maintenance. So the preventive maintenance of electrical system is that you need to do irregular inspections. And when we are talking about regular inspections, you need to check the system for wears, for damages, or overheating. It is very common with electrical system. Overheating is very common with electrical machinery. Okay? Electrical machinery most of them suffer a lot from overheating. So you need to do these regular inspections on them. And you need to inspect electrical connections also. Okay? Check your wiring and check the components. It's very important. Sometimes you may have a loose connection. Sometimes you may have a dangling connection. Sometimes you can have a burnt connection already. So you need to actually check, because if there's overheating, some parts where you have actually connected or joined together might actually be suffering from burnt. So you need to check this occasionally. When you are performing maintenance on electrical machinery, you need to do cleaning. Dust alone can make you to lose a proper connection, especially in some electrical system where they use all these connectors. I know many of us actually use a connector, just to actually connect supply from one particular joint to another. So when you use most of these connectors, try as much as possible to make sure that the place is well dusted. So in most cases, we use blower and then we set it to a very good or moderate pressure, so that it will not affect most of the things that the wires that are dangling and all that. So we direct it to all those joints or all those junctions that that you have done some connections where there may be dust already covering the conducting area and all that. You direct it to that place. You blow away you blow up the dust to make it clean. Perform cleaning. Sometimes some people use brush. Some people use this compressed air that I mentioned of. So electrical system also must be well lubricated. Okay, and these lubricants are actually being applied to the moving parts, like I explained about frictions and all that. So you also apply lubricant to the bearings and to the gears. Some of them are also using gears. You will apply the bearing must be lubricated, because it's actually rolling. We have different types of bearing. We have roller bearing. We have the one that is like a needle for very, very small. If you know that if the space is kind of tight, they use needle like a bearing. There are roller bearing. Okay, there are ball bearings. So they must be well lubricated. Use correct lubricants. You know, in every system I've been training on, I've been mentioning that there is a need for you to use, you know, the recommended lubricants. It is very important. Okay. You must also carry out some tests when you are maintaining an electrical machinery. Like you test for the voltage. You still want to know if the voltage that is getting to the system is still the required one. In every time we go for our maintenance on electrical system, on our drives, on electric motors, we do this. So you check for the voltage, if it's still giving you correct reading, the current, you test for it, you test for resistance. Okay? And in doing this, we make use of what? Multimeters. You can use your oscilloscope for you to see the variation in the voltage, that's the frequency, for you to actually see it. And there are other testing equipment that you can also use. You can also test for continuity. Okay, I'm going to elaborate on this. You can test for continuity. You can test you can do insulation tests to be sure that the insulation of that the insulators have not been broken down, and that you are not going to be receiving shock from the system. I'm going to actually elaborate on this. I'm just briefing it. The corrective maintenance on the electrical system or machinery, that's talking about the troubleshooting, because corrective maintenance has to do with repair. I made mention of that. When a system or a machine runs to failure and you have to repair it, that is, bring it up to function again. That's what we call corrective maintenance. We have explained this a whole lot. So what you need to do is for you to first identify the source of the electrical faults. You need to know what is wrong with the system. Okay, which part of the system has actually failed? That's what you need to troubleshoot for. And then in doing that, you can use some of your testing equipment, or you use the diagnosis tools. You can also use observation. You can, in some ways, some people will power on the system. They want to see if the electric motor is struggling, is struggling, like, is trying to work, but it's just like it's struggling like somewhere that is overloaded. So you can know proper places to actually go, or you can use your multimeter to carry out the troubleshooting. Then you either repair your electric motor or you replace. There are some factories, some companies that I've seen. Once the electric motor is faulty, they bring it out and they replace it. But in most industry where I've worked, they will send it to the workshop. So they always have, spare rating of different electric motors. They have them in the workshop. So if it's, for instance, if it's 3 kilowatt motor, so that they can guide against downtime. If it's 3 kilowatt motor and they couldn't repair it on the spot, they kind of just rack it out, uninstall it, bring another one immediately, install it there, and take that one to workshop so that they can work on it, repair it, and make it ready next time they have to replace another system. So that's how they actually repair. So sometimes you may not be able to repair on the spot. You have to replace it immediately and repair that one if it's something that you can repair, especially anything that has to do with the windings of the electric motor. If it has to do with the windings of the, and hardly will you see any of the electrical machinery that is not actually using drive, or that is not using electric motor. You deal with them. Your fan, okay, it has a motor that is actually controlling it. Your, what is it called? Your fan beds, okay, it has an electric motor that is also controlling it. So anything that has to do with rotation, mostly across industries, they're actually using drive. So you should know that you can replace immediately and repair that one later. So there should always be spares. So you can also use the OEM. We call OEM the original equipment manufacturer. That's OEM. So you can use OEM or equivalent parts to ensure compatibility. So the original equipment manufacturer, they will give you, if you use them, if you consult them, you'll be able to know which spare part is compatible. That's what OEM is actually functioning, is meant for. You need to know which part is compatible with the machinery that you are dealing with, so that you not go and put the parts that's supposed to be in Honda and then you are using it in Toyota. That's what we are talking about. So you need to consult towards the original equipment manufacturer. Okay, you use their information. Okay, you use that information for you to actually know, what to replace in the machine and the one that is compatible with it. So you must use what is compatible with it. There are different kinds of bearings. You can't just carry any out bearing and say, oh, the bearing is bad, and then you want to bring the bearing in. Okay, if it's capacitor that
So sorry, everyone. We apologize for that break in transmission. It was due to some little network glitches. Please kindly bear with us. We are trying to restore. We are trying to restore the network to restore, so that we can get back on the class. So I sincerely apologize for this. All right. Okay. Apologies, everyone. Okay, can we all hear? Okay, sorry, like I had mentioned, apologies. So we are going to be picking up from where the resource person stopped. Yes, because we are using one of our recorded classes to facilitate this class. So please kindly bear with us. So we'll continue from where you stopped. Thank you very much. So please let's continue.
People do this, and it is wrong and dangerous for the electrical machine that you are dealing with. Because the implication is that if the 15 amps fuse is replaced by 20 amps, so before, if any current that is above 15 amps want to pass through the system, what the fuse will do is to blow out. That is what the fuse is, just like a suicide bomber who will actually commit suicide. It will kill itself instead of your system to actually be damaged. So the fuse will blow out. So you can now imagine if you now increase the rating to like 20. So it means that it's a system that's supposed not to take more than 15 amps current. Now, if 16 amps current is actually flowing through it will take it. 17, it will take it. 18, it will take it. 19, which is dangerous for the system until it reaches 20 before it can actually shut down. So it is very important that you use the proper rating, okay, the correct spares, the compatible spare parts, to do your replacement whenever you are doing replacement. Do not join those league of people that, a lot of people take all those risks. They'll just say, okay, if I use this, it will work. Yes, it may work for a while, but trust me, it actually endangers the reliability of that machine. Okay, rewiring or reconnection. Before you rewire, before you reconnect, you need to actually try to check the wiring diagram. Hardly will you see most of our machineries or machines in across industry. Hardly will you see any one of them that does not have their wiring diagram. So if you are not skillful in reading it, okay, the electrical, the trained, the electrical department, workers must be able to read wiring diagram. So it helps in troubleshooting. So you will know where this one is coming from, where this wire is coming from, where this one is connected to this and that, and then you know where to be putting your multimeter probes for you to check if it's continuity testing that you're actually doing. So it is very important. Ensure proper connections and wiring practices. If the connection is not tight, sometimes you can be having what we call partial contacts. Partial contact is that what the conductor will make sometimes, and sometimes it will lose. It will make, it will lose. So
please, can we all hear the audio from the class? Okay, thank you very much. Thank you very much.
That will cause fluctuation within the system, and it will be as if, in fact, I have a very, very horrible experience with my car battery. There was a time I had a very bad day. It was a very bad. In fact, since my history of driving, I think that day was still, the worst, I could say. So what I was facing this day was that anytime I'm driving, I would just notice that when I enter into gallop, so whenever I enter into gallop, my car will just stall. That is, it will just, the light of the first thing I will observe is that what the steering wheel will be very, very hard to on, and then the dashboard lights will go off, and then my car will just go off. And driving in Lagos, that kind of experience in Lagos, it may actually stop on the main road. People will be hooting their horn behind me. Get off the road, get off the road. I was so tired. I will get down again. Okay. Hold on a bit. I'll start the car again. The car will move to some distance. Once I get to a place where, I enter into gallop again, it will happen. So at a point, I check. What could be the issue? Okay, maybe it's overheating. And fortunately and unfortunately, maybe coincidentally, I checked. I saw that one of the fans was not actually working. Okay, I put off the AC. I said, okay, maybe without the AC, it may actually work. I moved, my wife was in the car. We're going for an event. My car, was just stopping, putting off, to the extent that many people that live in Lagos, we know what I'm talking about. There are some places where your car should actually stop. Before you open your bonnet, you have to settle the boys, the area boys. They must collect money. I paid that day, because, there was one stoppage I faced, even around the show the year. So it was a tough day. Listen to all these things I'm actually telling you. Do you know that that same day I used an emergency mechanical workshop? They did so many things on the car, because that's not the workshop I normally use. They did so many things, change this, service the piston, service this, it may be this, it may be that. They did so many things. I spent about 3 hours there. Just, immediately handed over the car to me. I've not driven for like 20 minutes. The same thing happened. So I have to manage the car. That day I reached my house, called my normal workshop, and they told me that I should just find my way to get the car down. Even if it's just stopping on the road and all that, I should bring it the second day. In fact, they sent one of their guys to come and drive the car to their workshop. Do you know that the only thing that they did on my car that they troubleshooted is that I had a loose connection on my battery? The only fault that I suffered for that day was that I had a loose terminal on my battery. And I checked that day. I couldn't figure it out that it's a loose terminal. I said, no, it can't be a loose terminal. With that problem I faced, I argued with them. It can't be a loose terminal. They say it's a loose terminal because I left my car there for like 2 days. I fuel it. I said, okay, fine, just test it round. I want to be sure. The guy tested it. He said the car did not stall on the road. That he's very sure that it's just the loose terminal. Everything is all right. And trust me, I've never, that case, that kind of scenario has never repeated itself. Ever since that day where they changed the terminal of my battery, tighten it well, I got a battery seat that will fit in properly. They tie it down. That even if I enter into gallop, there won't be anything like shaky terminal. I never experienced that kind of thing again. And that's the kind of problem that loose connection can actually do to you. If you are working in industry and you have never faced the issue of a loose connection before, you may not understand what I'm talking about if you're in the electrical department. It has really, I've experienced it a lot. And it can scatter the system of any machine. When you're having, just imagine that somebody is fainting and waking up, fainting and waking up. That's how loose terminal actually works. Somebody is fainting and waking up, fainting and waking up. It will be tiring to the system. So it can disorganize every other thing in the system. So partial contact is that it's making, there will be supply, it will shake, the supply will go off. So you have to tighten all the terminal properly. It's very important. Now, what are the common issues that you may have? The common issue is that I've told you, most of the electrical machines, they suffer from overheating. Okay? Overheating of the system. Okay? Electrical components overheating, wiring or connection overheating. So you have to look out for this. Short circuits. Short circuits happens to be if the conductor carrying live, that's the live conductor, short with the with the ground. That's the neutral. Let me try to bring this up. Let me bring up my whiteboard so that we can see what I'm talking about. I don't want to assume that we are all electrically oriented, okay? Okay. So, of course, you know that even the mechanical guys know that. So there is always live, there is always neutral. So if this actually was short with this, that's what we are talking about, short circuits. So if this wires that are supposed to be parallel to each other, they're supposed not to meet. So both of them are supposed to go like this. But in case of short circuit, is that both of them now touch. That is short circuits. So that you can look out for that kind of fault. And it can happen when there's overheating. There are some wires that they pass through the same pipe, okay? So there is a pipe, okay, and you lay the wire through them. So if there's overheating, one of them or both of them can lose their insulation. So if the insulation peel off, the insulator peel off here. So if this place should short together, there will be short circuits. So, and unless you are able to actually troubleshoot and see that there is continuity. So when you perform a continuity test between the two wires, there's a way you can perform the continuity test between the two wires, and you see that there is a flow or low resistance between them. So it shows that they are touching somewhere. You have to trace that wire or trace that connection and resolve it. So that is, I'm going to actually elaborate on that when I'm talking about using the multimeter for testing. I think I will elaborate on it. Okay. Okay, my slide is back. So check out for corrosion. Okay, the corrosion of the component, electrical component or the wiring component. The power qualities also, in most cases. I had a very funny experience with this. There was a time we were resolving a fault, okay, on VFD, variable frequency drive, okay. So we're resolving it, and anytime you are working on it, everybody that has worked on that equipment before will know that instrumentation will come, the power will come, that's electrical will come. So most of the problem on VFD, in most cases, is actually the instrumentation aspect, because it has to do with the electronics aspect. Because the only thing that the power will do is for them to test the voltage that is going into the input. So once they test the voltage and it is the correct voltage that's supposed to go in, and they will not go outside and see that it is not giving maybe the correct voltage is supposed to give out. That means that there is a problem in the electronics system. So they have to, because VFD is used to vary the speed of electric motor. So they use it to vary the speed, and in most cases the system it uses is that when the AC come in, they convert it to DC, and then they alter it back to AC. So in that case, you are already altering the frequency, and then altering the frequency will affect we also alter the speed of the electric motor. So the horrible experience was that the power guy came, we were there, where the power, and the instrumentation guy came. He tried that he didn't know the fault. So he said it's the power issue. We just carried the multimeter and then we tested it for him. Say, see the voltage. So when he saw that it was correct voltage that is coming, he said, I don't like the voltage. I don't like the voltage that is coming. The Indian guy that led us had to burst into laughter. You don't like the voltage. You are seeing the accurate voltage. You don't like the voltage. So voltage, does voltage have a skin color? Does it have skin color? Do you have black voltage or white voltage that you say you don't like the voltage? We were just laughing because he was actually confused. It used to be, one of the instruments that normally give the instrumentation department, normally give them headache a lot, okay, to troubleshoot and resolve in the company where I've actually worked. So we're just laughing at it. How will you say that you don't like the voltage that is coming in when you can see that it's the correct voltage? So you have to check for voltage fluctuation in most electrical machines. The problem usually is the voltage fluctuation. If the voltage is not steady, okay, that's why you see some electronics gadgets that use steady they use a stabilizer, all these TV guard that you use in your house and everything. Most of them are just to stabilize the voltage that is coming, because the equipment needs a steady voltage in order to function well. Okay, so you see all these your freezer that use a relay and all that. The relay or those transformers that use a tap changer just for them to actually adjust. Depending on the input voltage that is coming, the tap changer will just adjust itself so that it can produce a steady output voltage. So the voltage has to be steady. What are the tools and equipment that we use? We use multimeters. I've explained this. Oscilloscopes that is used for you to actually measuring or to monitor this voltage variation in the voltages. So it will display this like a graph for you, like a waveform graph. You see the fluctuation in the voltage. Or some people will say it is used to actually measure frequency, just for you to know how steady the supply is and how disturbing the signals that is actually coming into the system is. So we use thermometers, okay, to measure temperature, because I explained that most of the problem with electrical system or machines is overheating. So you have to monitor the level of temperature. Excuse me. So every system has the temperature that it can actually withstand. It has the temperature that it can withstand. Mr. Moderator, are you there? Okay. What are the safety precautions? Okay, your PPE, we have mentioned this, still remain the same. Your LOTO remain the same. Your electrical safety, like following the electrical, the working, the procedures. You have to follow the procedures. If it's a confined space entry, you must also follow it. The best practices is that manufacturer's instruction, I've made mention of this. Proper tools, the personnel should be trained, and then you must have the procedures being documented, and then we have some regulations and standards. When we are talking about electrical machines, most cases across industry, what you have is the motors and the drives. Okay, you have the motors and the drives. Okay, so because without if you have any moving parts that you need to, if the machine must actually move, definitely there must be motors that is actually electric motors or drives that's actually driving it. And all these preventive maintenance that we have earlier mentioned about electrical machineries also stand with them. The corrective maintenance is also applicable to them. In your drives and your motors, okay, what you can actually have as common issues that there can be overheating. I've mentioned it that generally is applicable to electrical machines. There can be drives overheating, motor overheating, vibration. In most cases, your motor will vibrate because there is always coupling system. Coupling system is, or if it's not coupling system, the place where your electric motor is being mounted, that's the stand on which the electric motor is actually being mounted. If it's not stable, or if it's actually, sometimes it is bolted to the ground. If the bolt has removed, there will be vibration in the electric motor, and that will affect the proper and smooth running of the electric motor. So you have to check out for vibrations, misalignment. There may be misalignments. Okay, it happens a lot, especially if it's a belt coupling, if it's chain coupling or anything like that. So there may be misalignment. So you have to check for misalignment. In conveyor belt misalignment, there are some sensors that they normally make use of. Like in one of the companies where I work, we have what we call sway sensors. So that sway sensor is just like a plunger. Let me show you how it looks like. So we call it sway sensor. Sway, so that the belt will not sway off. So if this is the belt, so you have the sway sensor that is actually being mounted around here. It's just that you are putting human arm around here. Okay. So if this belt should sway towards this direction, it will turn. There's no way it is positioned in a way that if the belt should actually shift, the belt is usually on rollers. So it is rolling like on drums. So this is the belt there's roller beneath it. So if this belt should shift to this direction, it will actually touch this way, this sway switch. It will turn it. So when it turns it, the output is actually to any alarm or to any trigger. So in most cases, the interlocking, when we're talking about interlocking is done in electrical wiring such that you can actually have the safety of the machine. For example, okay, let me try to break this down. Okay, let's say we have these belts. These conveyor belts. Conveyor belts. Okay, these conveyor belts. And these conveyor belts always lead, it always maybe the material that is coming will actually be filling up this place. And that material supposed to be passing through these chutes. We call it chutes. It's supposed to be passing through these chutes, okay, and land on another bed that will take it to another unit of the company. So you can see this is the section A, this is the section B. In this section A, the material is coming in, it will pass through these chutes, it will fall inside these chutes, and from that chute, it will be falling on another bed that will carry it. So there is a way we can put a level sensor, because sometimes this material can actually clog around here, such that it will not be dropping on this bed B. It will just be clogging like that, like something is blocked, and the material that is coming in will now be dipping up. It will be dipping up. So there's a way we can put a level sensor here. Maybe a level sensor, something like that is using proximity sensor or level sensor that is actually sensing the height of this material. Once this material has hit up here, so we connect the output of this sensor to the electric motor that is driving this bed, such that once this sensor is giving an output, it will switch off the electric motor that is controlling this bed A. So the bed A will switch off immediately. Why are we switching it off? So that more materials will not be coming here and it will not be wasting or be falling off. So the process guy will compulsorily have to come to this unit, declog chute, make sure that what the chute is free now, and now when it becomes free, they can now what, tell the control room, they will power up again and the system will continue running. So we use this for interlocking, that if there's a problem in this particular unit, let this particular unit be switched off. So we can say if there's a problem in what? Unit B, let unit A be switched off. So we call it interlock. Interlock, that is, you are locking them together so that there will not be what? A major what? Problem or wastage along the line, or any threat to safety of the equipment or to that of the workers. So the same way, that's how that sway switch also works. Because if these beds should actually sway away, all the material that is here, they will waste. Sometimes the process guy will have to come and manually be packing those material. Okay, so what they do is that once this bed is swaying, that is drifting off the drum on which it is what's being driven, is drifting off it. It will touch this sway switch, and this sway switch will activate, okay, an output that will switch off the electric motor that is driving this bed. So this bed will have to what? The electric motor that is driving it will have to go off compulsorily. Now, when we come there, we will see that what? Oh, the sway there bed is actually what? In fact, the sway switch that you have here, the fault, the error will show on the system at the control room that, oh, this particular sway switch with code number, so it must have had its own identity number. They will go there and see that, oh, okay, the bed is already swaying. They will now adjust the alignment of the beds. Okay, once they align the beds, okay, and return the switch to its normal position, that's when they can power up. So misalignment, or coupling system is a very big issue that you should work out for when it comes to electric machines. So let me bring up my slide. If you are with me, can you please give me thumbs up? If you are still with me in the class, give me thumbs up. Hey, my people are with me. Thank you so much. Thank you so much. Thank you so much. That's great. Thank you so much. Yes, we are moving with a very good, we are moving with a very good speed tonight, so it's fine. So I've discussed the tools and equipment. The vibration analyzers can also be used. The safety aspects remain the same. What is the best practices? Follow the manufacturer's instruction, use proper tools, train personnel, document procedures, and then examine the standard. So I've discussed all that. So your electric motors also, we have different types. We have direct current, okay, motors. Those are the ones that require steady voltage. We have the AC, that's alternating current. I don't want to be going into theory of that, but I've done a lot of analysis for you in the material here. Okay, I don't want to be touching the theoretical aspects of it. So, but the one I want to talk about is the inspection, the testing. Okay, what are the testing that you need to actually carry out on your drives or electric motors? There's what we call no load testing. No load, I think in the first day of the class, I briefly mentioned this. No load simply means that what? You will disengage the electric motor from the load that is actually driving. You will remove the load and try to actually run the electric motor and observe it, listen to how it sounds and everything. So with that, you can, know if there is any problem with it or not. Let me give you an illustration of that. Sometimes when they perform a particular maintenance on your car, okay, you may be at a spot. The mechanic guy will tell you to raise it. They say you should raise your car. You want to listen to how it sounds, okay? And after you raise it on no AC, they will not tell you again that you should actually put on the AC. They want to listen to the engine, okay? So if the engine is fine, or if you are driving automatic, if there is if they want to test for the selection of your gear, the automatic gear, they may actually have to fire your car just to drive your car around to see if it will be changing gear automatically. So there is a way they actually do all this tests. So you can do a no load testing. So test the motor without what? A load, so that you can check out for unusual vibrations, noise, and overheating, just as I've mentioned. You will now do what we call load testing again. So in load testing, you are going to actually what? Now load it. Couple the load that the electric motor is driving, couple it with it, and then you observe it, okay, to see if the rotation is fine, if the torque is fine, that's the spinning, the rotation is actually fine, that's the movement, okay, is actually what? Fine. I don't want to go into too much theory with that. So you check the efficiency and all that. You also test out the insulation resistance. Okay, you test for the insulation resistance. I will come back to that. I'll talk about that when I'm talking about testing with a multimeter. Okay, I'm going to explain that. We have an overwhelming. So another electrical part that needs maintenance is your VFD. I've mentioned this. I said VFD is actually used to actually what? Alter the speed of your electric motor. You know, there are some electric motor that you don't want to drive them on a steady speed. For instance, let me use my experience. Okay, back then in the cement factory where I work, okay, we have a conveyor belt that runs from mines. I think about 10 kilometers. 10 kilometers. So that conveyor belt. So let's say this is mines. This is the mines. And this is the factory, very far from the factory, very far from the factory. So this, when the mines is where they do the blasting of limestones and everything. So they do the blasting of, in fact, that's where the raw materials we use for manufacturing of the cement. That's where they are. So there is a conveyor belt from the mines. I just want to tell you, because these belts actually make use of VFD. They use VFD to drive these belts. And I want to tell you some kind of equipment that make use of VFD. So materials we have to come from mines, okay? And then, you know, these materials will be going to what we call mixed storage. That's where they actually store them, mixed storage. So sometimes there may be, you know, a very good production going on in the factory, that all the storage that we have in this mini storage, we have almost exhausted them, and they don't want production to stop. They want production to be, you know. So what do they have to do? They need materials urgently and very fast from mines down to the factory. So in that case, they need the electric motor that is driving this belt to work at a very fast speed. So that is why they need VFD there, so that if you want it to work on a fast speed, okay, you can achieve it. If you want it to work on a slow speed, and I will tell you, this is the case where we need the material, and then this drive has to work very fast. So we need a fast speed. Another day, it might be that the production is going on and the mini storage is already filled up. The mini storage is already filled up, and yet the material keep coming from mines. They are still blasting, they are still sending us material. So what do we want to do? We don't want this, we don't want too much of a materials again, because the material in the mini storage is already, you know, we have heap of them. So we have to drive these beds at a very slow speed, so that the material will just be coming, will just be dropping little by little. It will not be fast. So that is why the electric motor that is driving this, they couple it with what? VFD, variable frequency drive. Some people call it VVFD, variable voltage, variable frequency drive. So what we are gaining from varying the frequency is that we are varying the voltage, almost like doing the same thing. So when you vary the frequency, okay, definitely there will be variation in the voltage, and that will affect the speed. Either the speed will be high or the speed will be low. This, you can compare this one to the way your fan regulator works at home. Okay, even though this one is just resistance, we are just adjusting, just like you are making use of rheostat in a particular system. That's a variable resistance. So if you put it on 1 or 2 or 3 or 4 or 5, what you are simply doing with your fan at home is that what? You are either reducing the resistance, and we know that what? The lower the resistance, the higher amount of current, the higher amount of current will flow. And when the resistance is high, small amount of current will flow. So resistance is actually what opposes the flow of current. So if you put it on 1 and the resistance is highest at 1, definitely the speed of your fan will be lowest at that time because only little current will be able to flow through. But when you set it to 5, let's say 5 is where you have what? Smallest what? Resistance there. So it means that enough current will be able to flow through, and there will be enough what? Flux that will be generated, and there will be high speed. So interwoven, this thing is just like is interwoven. I'm just using the domestic example for you to understand how it works in the industry. So that kind of equipment, which is VFD, being used to achieve variation in the speed of the electric motors. Of course, we know what electric motors are. We use them to convert electrical, to mechanical power. So we are converting electrical power to mechanical power, okay? Based on what we know as a conservation law of energy. Energy cannot be destroyed or not created, but can be converted from one form to another. So you are converting the electrical to mechanical in such a way that what? Now the input to electric motor is what? Is electrical power. But the output energy that we are having is the mechanical power. It's either driving something, maybe a conveyor belt or a chain or a particular thing across in the factory. So maintenance of these also follow what we have actually explained on the drive. So you check for signs of wears, the damage. Let me bring up my slide back. Oh, I have some other thing. Can you see my slide? If you can see my slide, please, thumbs up. I brought back the slide. Thumbs up if you can see my slide. Thank you so much. Thank you so much. Mr. Moderator, are you there?
Yes, I'm here. I'm here, sir.
Okay.
Thank you.
So, the preventive maintenance on a VFD, check for signs of wears, the damage, overheating. Okay. These are general things that you look out for. The wiring, the connections, and all that. I don't want this to. So it's just like the same thing that you do on drive. I've explained all of them. Overheating. Okay, the safety aspect is still what? The same. In industry also, we also have the maintenance of sensors and actuators. Okay, is there anybody here who can give me a name of a sensor in your company? A sensor in your company that you make use of very well. There are different kinds of sensors. Proximity sensor, thank you. Proximity sensor is very common. Okay, proximity sensor is very common. They want to know if this thing is actually still in the position or not. They make use of proximity sensor. Emmanuel, you have one that you wanted to mention?
Capacitive sensor.
Okay, thank you. So we have a whole lot. We have how many of us have you have your, what's it called? Level sensor, right? Do you make use of level sensor in your company too?
Yes.
Okay. Sensor. Yeah, thank you. Thank you. So we have maintenance of these sensors also. Okay. Actuators. What are the use of actuators? Actuators are actually what? The component of the machine that is responsible for movement. Okay. So it's actually the one that will convert the energy source. Whatever the energy source of the machine is the one that is converting it to mechanical energy, which is the movement. So actuator is the one that causes movement in the machine. So we maintain them also. And their general maintenance also is not far-fetched from what we have discussed so far. You have to clean your sensors. In fact, most of the problems that you have with sensors is when they are covered with dust. By that proximity sensor, it must, or the infrared, the one that is using infrared, that is using lights, you have to clean it. There must not be dust actually covering it. This is very important. So you clean it, you clean both the sensor, you clean the housing of the sensor, okay? Because of damages. most of them are always being housed in a case. So you clean their casing, you clean the sensor itself. That sensitive part of it, you clean it, and in cleaning, you must not clean it with material that will damage it or that will scratch it. You must clean it, it's just like something that is delicate. Okay? The calibration is also important. You have to calibrate your sensors according to the manufacturer instruction. Please, mute, please. Take care of that. All right, thank you for your cooperation. So ensure that it is well calibrated. Your inspection about the wear, about damages. Sometimes your sensor can be damaged. Okay, there was I think it's my car, because what they had to do in the workshop for me was to just bring out a particular sensor. Okay, it was actually giving me issue. I think there is a shock sensor, maybe a shock sensor. There's a shock sensor, in some cars. My car also have that shock sensors. I don't know, but in all these modern cars, there are shock sensors there. I think they had to work on my shock sensor that day because it is covered with dust already. Okay, so most of these sensors, they will not work properly if there is dust, if there is damage on them, okay, corrosion on them. And in most cases, when they are down, you have troubleshooted, you see that it's actually the sensor that is giving you a problem. Replace them. In fact, I hardly see where they actually want to repair sensors in the industry. I hardly see where they have to repair. In most cases, they replace them if you want to have an accurate result. Okay. Don't forget to also consult your OEM. That's original equipment manufacturer. So actuator maintenance. Actuator maintenance, I've explained that it is the actual part of the machine that causes movement. So when I mention movement, you should know that you are going to need lubrication. So you lubricate. Actuators must be lubricated. You must actually inspect them, okay, for the sign of, since there will be friction, in them, there could be possible friction in them. So you have to check them for wears, damages, corrosion, okay. You test them also to test out their performance, and in most cases you replace them when they are giving you issues, okay. The common issues with your actuator: drifting or inaccurate movement, okay. There was a time I was driving and I was feeling the vibration. You will definitely know that something is wrong. When you are working with a machine and you see that though it's moving, the actuator is actually, the movement is actually happening, but you know that the movement is not normal. You will know, because that's not your first time of using the machine. It will be an irregular movement. So you should watch out for that. That can also be due to faulty wiring. You should check out for faulty wiring or faulty connections. Now let's talk about testing equipment. I'm going to really discuss multimeter, because I want to give enough time. I really want to give some time for us to discuss. I need questions, I need feedback tonight. Moderators, we have to also address you on how to go about your assessment and all that. So I don't want to use my time on dots. So testing, let's talk about testing, and that's the multimeters. What do you use your multimeter for? You can use your multimeter for different electrical testing, but at least we are a mechanical person online even tonight, so we will look at it together. You use your multimeter for measurement of voltage. You can use it to measure voltage, okay. You can use it to measure voltage. You can use it to measure current, because these are the things. These are the parameters that you must actually measure for you to know if your electrical machine is working fine or not. So you have to know if it is working under correct current, the correct voltage, okay. And we have different. You can have the one that is digital, your multimeter. You can have the digital one, or you can have the one that we call scale, okay, the one that is using scale, okay? Analog. Yes, we call the one with scale analog. So I want to see if I can actually display the two of them. That's what I'm checking, the digital and the analog. Let me see if I can display it for us so that I can use that one for explanation. Okay, so this is the digital multimeter, okay, and this is your analog, okay, multimeter. So that one is actually using what is working based on scale. But not to disturb yourself, I recommend that what you use your what digital, because you'll be able to see. It's not like you're having issues with your sight. You'll be able to see the number that you are actually what measuring. But what we just want to explain is that how do you use this to measure your voltage? How do you use it to measure your current? How do you use it to measure your resistance, your continuity test, and all that? And why do you need all this? So that's what I'm going to. Let me use my whiteboard. So as you can see, you have your probes. You have what we call your probes. Okay, your probes is what you use to actually touch what you actually want to test on. Let's say, for instance, we want to test for, let's say there is a connection here, live. This is what neutral. So we want to know the voltage that is actually what in this what machine. This is a machine. Okay. So in your multimeter, okay, you will see that in your multimeter here, okay, I don't know if this one is, but of course you can see V here. This is V around here, okay. So if you see, you can use it to test for voltage. That's what we call it multimeters. Multimeters means that what you can use it, you know, to test for multiple parameters, electrical parameters. There are, you know, if you are talking about with the instrument to that you need to use to test for your voltage, that's voltmeter. It's supposed to be voltmeter you will use. If it's instrument that you need to test for your current, it is a ammeter. If you are looking for an instrument to use to test for your resistance, it is ohmmeter. But we now have one that is like built for all these parameters. So that's why we call it multimeters. So when you are using multimeters, you need to, if you, whatever parameter you want to test for, you must set this your knob. You must set it to that parameter. So if it's voltage that you want to actually measure, you have to set it to that voltage. And don't forget, if you are setting it to voltage, you should know the kind of voltage you want to measure in the system. Is it also an AC or an DC or a DC? That's what we now talk about your probe. So look at these holes that you are seeing here. These four holes here, okay? These 4 holes, you know, they guide you on where to actually put the 2 probes that you have. The probe look like something like this. This is your probe, okay? So you can see the wire around it. So it has a ball or pin mouth, okay? So your probe will go into, that's the red one, okay? The red one, you put it in the terminal that reads something like V, you know, some of them will show ohm, you know, ampere. So the red probe will go into this particular place. You connect it into this place. And then the needle mouth, just manage my drawing, will be like that. So the other O, you see it as common, which means grounding, or the negative aspects, or the return for the for the flow to complete the circuit. So you put your black, this is your red, you put your black, okay, in this, your black probe, you put it. So this is the 2 mouths that you will use to touch, you know, either this, and you touch this. Don't forget, while you are doing this, your knob has already been set to the voltage you want to measure. And you should actually know the quantity of the voltage that is specified on that system. So it's also on your multimeter. So that if you want to test for, let's say, something that is more than 200 volts, and you are now setting your probe to where they wrote the maximum of what? Maybe 150 volts. So you can see that you will damage that multimeter, because the amount of voltage that you have set to is lower than the voltage that will flow through it. So you must set it to what? A correct voltage for that particular measurement. So you put it here, and then if it's your digital or your analog, it will display the voltage in the system. Now, when you are testing for voltage, you should know that testing for voltage is done on a live circuit. Live circuit means that the system is powered. It has to be powered. Okay, so you don't test for voltage on a dead circuit. You test for voltage on a live circuit. The same thing you will do when you want to test for current. You go back to your knob. Okay, you look for current. That's the ampere. Like, you look for it. Okay, it's somewhere down here. So you will set it to either your red probe will be on. Your red probe will go to either you set your knob to either DC, current. So you see it as DC, or AC current. So if it's AC, you are measuring your knob should be set to what? AC. If it's DC, you are measuring, your knob should be set to what? DC. Why I'm mentioning this is that you have to be very careful to make sure that the parameter you are measuring is what you set your multimeter to. If not, you will damage the multimeter. A lot of cases like that for so many people that don't know how to use multimeter. So you will check that parameter. Make sure you set to the knob to the correct, measurement. And then you use your probe well. Your probe for the current also will still be on this. As you can see here, it can measure voltage, ohms, which is resistance, or your ampere, which is current. So milliampere. So it can actually measure it. Your red probe will still be there, and your black probe will still go to com, and then you measure again. Again, you can test out for current on a live circuit. It is only when you are testing for your resistance that you need to actually make sure that you are working on a dead circuit. You are testing for resistance. Test it out on a dead circuit. That is the circuit should not be powered. And why are you testing for resistance? You really want to see if amount of current that will flow. If that resistance is high, it means that low current will flow through it. And if the resistance is low, it means that higher current will flow through it. And when you are setting your knob, that's your knob, you set it to your ohm. You will see a symbol like this, okay, which is your ohm meter. Okay, you set your knob to that ohms, and with the correct rating, also check it. What is the rating that are there? Is it 50? Is it 100? And you know the kind of the resistance you are expecting from the system you want to measure. So you set to the correct measurement, and then you test out resistance. Another test that you can actually carry out is what we call continuity test. And in most cases, continuity test skill is very, very important. It is very, very important when you are troubleshooting. Why do you have to test out for continuity test? There are some times that maybe you have a supply here, okay, and the machine is here, okay, and the major from the breaker, the power actually enter into the supply. It enters into the breaker that you're actually using. So the supply enter into it. But the machine here, anytime you power it up, it's not coming up. So this is the conductor, okay, that leads to the machine. This is, let's say this is live, this is neutral. Okay, this is the machine. So you put your multimeter around here. You see that it is actually giving you correct readings. But you come to the machine, the supply is not reaching machine. What could be the problem? Of course, if somebody started a journey, God forbid, and you call the person's destination, they say the person has not reached the destination. What happens? The person must still be on the road. So it means that our current is actually trapped somewhere on this conductor, and it's not getting to the machine. So in a case like that, you want to test for what? Continuity. Maybe the conductor has actually cut inside. So you may have to what? Open the wire around here. Okay. You open the wire around here. You first test from point A to point B here. You put your probe. Okay. How do you test for continuity? Go back to your multimeter. Let me see if it's clear. You will see a symbol that looks like what? A symbol of your diode. Let me draw it for you to see. You will see something like this. So this is continuity. Continuity means that what? Is there any continuous flow between them? So you set your knob to something like this. So this continuity, okay? And then you put your probe also, okay? Properly, you set it to continuity. You put your probe on that particular what called your red probe should be put on this, where you see this what symbol, and then your COM should be put on what? On the black should actually be put on what? On COM also. And then you come here, you put your probe here. Any of the probes can be used. You put one here, you put one here. So if the multimeter beep, or if there's any low resistance being read or displayed, it means that what? There's continuity between here and here. That means that your wire does not have problem from point A to point B. You put another cord here, which is point C. So you test from between B and C also to see if there's any continuity. Anywhere you do not get any beep, or you get a high resistance, it means that there's no continuity there. So this wire already has a problem around this place. Is either you cut it off here, you replace it with a good wire, you join it, or you completely replace the length of this wire, okay, and resolve what? The problem. So continuity, multimeter, usage of multimeter for testing is very, very important when it comes to electrical maintenance, electrical preventive maintenance, electrical corrective maintenance. When you are repairing, when you are troubleshooting, it is very important that you should be skillful in it. I've promised not to use all my time, and I'm tempted rather to use another 5 minutes. So let me try to bring everything together. Yes, we have done well. I think I've touched mechanical, the control system, the electrical, hydraulic, and pneumatic. So I want to appreciate everyone. Yes, you will have the rest of the analysis in the material. So I want to appreciate everyone who have explained about short circuit, the ground fault. Okay, let me briefly just explain this. Another issues that many also normally have with electrical system is in the case of the grounding and the earthing. There is a big difference between earthing and grounding. Okay, grounding is when you connect the conducting parts of, the conducting parts in a machine. If you connect it down to the earth, okay, that is grounding. Earthing is when you connect the non-conducting parts. Okay, let me see if I can bring something up for you. Earthing is when you connect the non-conducting parts of a machine to the ground. Okay, and the main purpose of doing that is for you to prevent shock. Okay, it's for you to prevent shock. I want to see if I can actually display something, okay, that would show you earthing and grounding. Okay. Of course, many people normally mistaking this. They will take maybe the earthing and the grounding, but they actually what different. Grounding, you connect the conducting parts of the machine. You connect it to the ground. Now, the major purpose of doing that in electrical is just for you to balance the load. Okay, if there's any leakage current, so that will not make the load to actually balance. Okay, you connect it to the ground. But why do we normally connect the body also to the ground, which is earthing? because of shock, in case you can have the conducting part, perhaps maybe if the insulation fail and it's actually touching the body of the non-conducting. So now the non-conducting is now conducting. So when we connect it to the earth, that is when we hurt it, it will prevent shock in case if the operator mistakenly actually touch that part. So this is very important also. So you check when you are maintaining your electrical machine, you have to check the earthy parts and also check the grounding part. It is very, very important so that you can be rest assured that as the maintenance engineer or as the employee that is working on it, that your safety is actually guaranteed. It's very important that you should look out for this. So moderator, I think I should stop there. I want to see if I can give us an image of the earthing. I love to be practical with that. Let me share my screen. Let me see if I can show you an image. Okay, I think I got one. So can we see my screen? Can you see my screen? Can you see my screen?
Yes, you're pretty good.
Okay. So you can see earthing here. So you can see earthing. So you see this pipe now. This pipe that you are seeing is just the body. Is a non-conducting. This pipe is not expected to actually conduct anything. So that wire that is connected to it and earthed is just in case, because this pipe here is housing the electrical conductor that go through it. So it's not expected to conduct. But let's say something happened. Let's say it rained and the insulation failed and all that, and it's now conducting. So what do? We hurt it so that there won't be anything like shock. But you see the other one, grounding. You can see that those cables that we use for grounding, they are connected on the conducting part, and they are connected straight to the head, so that there will be load balancing. Okay, there will not be disbalance in the load, and at the same time, it's also indirectly also protecting you from shock. So it is very important for us to also note that. So thank you very much. I want to appreciate you once again for being patient with me. As a trainer, I know I talk too much, Abi. Thank you so much. I appreciate everyone. So, Mr. Moderator, over to you.
All right. We want to appreciate resource person, Mr. James Fanny, for that wonderful session. Yes, has been an engaging one. Yes, thank you. Yes, many accolades are coming in already. Okay, so quickly, let us take questions. It's 6 minutes to the hour of 4. Let's take questions. Let's see what we can do within the remaining minutes we have. So please, if you have a question, just drop your questions or signify by raising up your hand. So I'll call on you. You can ask your question. And if you are in a place where you can't really speak, you can drop this in the comment section. And those who are following us on YouTube, yes, we equally recognize your questions as well. So please just drop your questions in the comment section. Yes, Anyong Bara, yes, he has been an ardent follower of the YouTube platform. Okay, so he's asking what is the meaning of VFD. Yes, I think the lecturer did mention that that's variable frequency drive. Okay, so Anyong Bara says, I want to ask about actuator. What are the components of actuator, and when an actuator is not turning a butterfly valve, how can you shoot? Okay. Okay. So, Anyong Bara, that's your questions. Okay, we'll do well to respond to it. Perhaps we have the luxury of time to do that. Okay. Oluwole Akinwumi, I can see your hand. Please, you can unmute your mic and ask your question. Oluwole Akinwumi. Oluwole Akinwumi, can you hear me?
Okay, thank you very much, Mr. Moses. Please confirm you can hear me loud and clear.
Yes, please go ahead. We can hear you now.
Okay, I have 3 things to say. Number 1, I want to give a feedback. Number 2, I want to make some observations. And then number 3, appeal in the next 1 or 2 minutes. Number one, let me quickly say, very thanks to this company for this wonderful training.
Sorry, Mr. Olwale, are you using an earphone? Are you using hands-free?
Yes, I'm using earphone.
Okay, because your line is not clear enough. Because I couldn't hear your question properly.
Maybe let me allow somebody to let me get a place where I can talk more in the next 2 minutes while I allow that person to speak first.
Okay, just try to do that on time because of the limited time we have. Okay, so do we have any other person with question? Any other person with a question? Just signify by raising up your hand. Okay. Okay, so while we await Mr. Oluwole to come back for his question, hopefully he does that before the time is over. We are going to be dropping the assessment for this course on the platform. So we have about 4 assessments for the respective categories that we have. We have an assessment on electrical maintenance, mechanical maintenance, pneumatic and hydraulic, also the automation and control system. So the assessment that we have covered on everything we have covered so far is going to be categorized in that 4 categories like I mentioned. So please watch out for those assessments. And please, I encourage you, attempt the assessment. It's a test of your knowledge, and also a requirement for you to get the certification. So like I did mention, the information regarding the certification for this course has already been posted on the WhatsApp platform. The timing for the discount offer is near. So try as much as possible to do everything possible to be able to tap into that discount offer. Yes, I think there's a provision for you can make payments in 2 installments or thereabouts, but it's for a limited period. For the installmental payments, you can do it in 2 installments. So just reach out to any of the admins on the group. And let me also sound a note of warning. Try as much as possible. If you must communicate with anyone on the group, reach out to the group admins. There are a lot of scammers on the groups like that, and they are trying to get in touch, trying to get across to you just to be able to do it. If you must communicate with anyone, if you have any information, reach out to the group admins. Yes, they will do their best to guide you through what you need to do. Okay, so thank you very much. Mr. Oluwole Akinwumi, are you back? Oluwole Akinwumi.
Okay, I don't know if can you confirm you can hear me now?
Very perfect. Please go ahead, sir.
Okay, thank you very much. Like I said, first I want to appreciate this great company for this wonderful training. It's been inspiring. It's been very wonderful, I must say, for these past 3 days. Thank you, and thank you enough. Secondly, my observation is this. As one of part of what is happening right now, I want to, since for the past 3 days now I've been on and I've observed critically, I believe there's always room for improvement. And one area I want us to really improve is on the training, on the subsequent
Mr. Oluwole, we can't hear you again.
Is to see how we can also our trainees. For example, now there are some certain terms or some equipments, parts, instruments that have been mentioned by the trainer today that some people have never seen before. Some people that are on this call today, some are students. Not everybody is an experienced personnel. And so I want to advise, or I want to suggest that in our subsequent training, let's see what we can do to add more images, pictorial view, to further explain whatever we are giving out to people that are attending the training. It will go a long way. For example, now you talk about temperature gun, you talk about sensor, you talk about hydraulic, you talk about generator, and so many of these engineering equipment. Some people have not seen them before. They've seen them, but they don't know how the pictorial view of it, valves, and so many other things. So I want to advise, or I want to suggest that in our subsequent training, let this thing be included. It will help us a lot. And then the third one is an appeal. I know when I wanted to log in yesterday, register for the certificate, I discovered that it's about 4 categories. I don't know how this great company can help to see. I know you have done the best. You have done you have done all your calculation, but I want to still appeal. For example, now I'm mechanically inclined, and then this training I want to believe is all encompassing. You cannot talk about mechanical without talking about electrical. And there is no one that will say he wants to totally talk about electrical without an element of mechanical. Even the electrical machine you are working on, you have an element of mechanical there. And so having to obtain different certificates for each of these fields, electrical, mechanical, and so on and so forth, I think, I don't know how you're going to help us. Personally, I'm appealing. If I attend this training as an electrical engineer, I should have a certificate that will tell us or that will cover this training, that at least I have been trained on electrical and on mechanical and other aspects, which is hydraulic and pneumatic, instead of obtaining one certificate for electrical, one for this, one for that. I don't know how we can compress the three together so that when I obtain one certificate, it can comprises of all the three areas covered. And then that will also help me not to spend much. That is just an appeal. Thank you very much for your attention.
Thank you very much, Mr. Oluwole, for that wonderful feedback and observations from you. Yes, like you did mention, yes, there is room for improvement, and we always transmit us. So that was why we give opportunity to hear people's opinion at the end of every of our classes. Okay, so Mr. James is going to respond to that alongside the, what was it called, the question we have from YouTube participants. Okay. So, Mr. James, over to you, sir. The question from the YouTube participant is that what he wants to ask about actuators, that what are the components of actuators, and when an actuator is not turning a butterfly valve, how can you troubleshoot? Okay, I think he's asking for how do you troubleshoot an actuator that is not working properly. Okay, so Mr. James, over to you, sir.
Thank you very much. So let's take it from questions. Perhaps we should take it from the last speaker. The last one you mentioned, let me first appreciate you for the suggestions about the training pictorial representation of most of those equipments. It's a very good one, and that is noted actually. So that if we have students here exactly who have not seen all these things before, they would be able to actually see and relate with it. However, I also encourage that, like I do tell people, engineering, what you do here is not just enough for you to go and relax. So when you do really receive the material, I want you to try as much as possible to study, because whenever you specify professional certification in your CV, trust me, most of the interviewers, they focus more in that particular category. So research. If you put most of these names that the contributor mentioned, the internet will show you a lot of things. Well, thank you so much. I'm a man of word, and however, there are many people that learn with pictures. For some people, if they have gone through some of our training before, there are some training that, trust me, in fact, what we did today, some people cannot deliver that training without just pictures and all that. So thank you so much for that contribution. The other one that you mentioned actually is always good in training. Our training is not complex, and we don't like our certification process to be ambiguous. That is why you see that in as much the world is craving for, mechatronics, they want people that can do like jack of all trades, they know mechanical, they know electrical. I still, by industrial relevance, there are still some industry where they maintain their stand. If you are electrical, if you are mechanical, just quite unfortunate that most of the companies in this part of Africa
they combine this work for most of their staff. You see somebody that is a mechanical engineer is already doing electrical engineer. These are not really let me say the international standard of operation. So that is why it is specified. It does not cost us anything to say, oh, this training, when you are done, okay, your certification is 80,000 naira. Another thing you will see is that there are some people, let's look away from you now. Maybe the work that you do requires that you should get little of electrical, little of mechanical there. There are people, because if you look at this training, this is the batch 4. We have histories of people who will just go for just 2 of the certification. They will say, okay, I'm going for mechanical and electrical. Okay, so I'm just going for automation alone, the control systems alone. There are some people that's what they deal with. It's just the automation aspect of the company they do. They don't need a mechanical for anything. They don't even need electrical. That is those people. That's why we kind of spell it out like that. Number 1, for everyone to be able to acquire what is applicable to their field, and number 2, for you to go for it according to your purse. So and it makes it much more relevant. So if you are a mechanical person in your company, you acquire the mechanical and you acquire the electrical, it can create an opportunity for you when they need somebody that can do little of electrical. So you have an experience in this, you have done the training in this. Okay, we can actually push this to your site to see how well you will do there. So that is why we put it there. And trust me, I want to let you know this. Even the first category, the second category, and the third category of discount that you are seeing there, they are nothing compared to the values of these certifications out there. I want you to, because many of us are here, of course, all of us are learned and we are relevant in the industry. Make your research to know what it will cost for you to acquire this certification out there, even with trainings that will not be as standard as what we delivered. Because I encourage you to rewatch the class. You will see that our class, because that's our goal in our company, they are scenario based. They are scenario based. I avoid so much to be doing can be defined. This is what it is and everything. No, we want to talk about the application, because that is engineering. Okay, so I cannot overemphasize that. So that is why we split it. We just advise that if you want to go for all, we have had history of people paying, a lot of people paying for the whole 4 certifications, Okay, so it's something that is applicable to you that you should go for. So the other questions about the actuator, just like I explained, actuator, they are devices, and what we actually achieve with actuator is just to convert energy into motion. So we want to convert energy into mechanical action, into movement. So that is what we use actuator to achieve in industry. So, and by the source of power, an actuator can be either electric, it can be electrical, like your electric motors, like your solenoids. Okay, so they are actuators. They can also be hydraulic. Okay, maybe the one that is actually fluid powered, some fluid powered cylinder. So you can have actuators in that form. You can also have actuators in a pneumatic form. Yeah, so you can have the air powered actuators. So that's what we use actuator to achieve. So just to convert energy to movement, to mechanic car actions. And where you will see them being used, you can see them in majorly automation, industrial automations. That's where you will see actuators being used. All these guys are into robotics, all these automotive systems, that's why you see actuators being used. But the technical one that you ask about, what happens when the actuator is not turning the butterfly valve? There are so many things that you can troubleshoot. But the very first thing that you need to troubleshoot for is for you to check the power source of the actuator. Sometimes, if the actuator itself is not really powered, there is no way it can actually turn the butterfly valve. So you start your troubleshooting from the power. You really want to know if your actuator is actually is receiving a power. Okay, either is electrically powered, either is pneumatically powered, either is hydraulically powered. So you have to check that. So when you verify that, okay, you may also have to check the settings of your actuator. If the power is not the problem, so what about the settings on your actuator, the configuration of the actuator, the calibrations, maybe the settings, is it okay? So you can also verify that. If that is not the problem, then you move forward to checking the mechanical linkage. There's always mechanical linkage connectivity between the actuator and the valve. So you need to be sure that what the connection is actually what proper. Okay. You may also check for obstructions. Valve movements could actually what be restricted by obstructions. Are there obstacles? Okay, maybe debris, maybe blockages and all that. So you can check all these, for you to actually troubleshoot what the problem is. So there are few other things that you can do, but that should surface because of our time. Thank you so much, Mr. Moderator. Over to you.
All right, thank you very much, Mr. James, and I want to say a very big thank you to everyone for being a part of this class. Before we leave, let's just take a feedback from one person. Please, we'll appreciate your feedback on the WhatsApp platform. Please, as we end the class, just go on the platform and drop your feedback for us. Thank you very much. Oluwole Akinwumi, yes, you can unmute your mic. Let's just have your feedback on behalf of your class before we dismiss. Oluwole Akinwumi.
Okay, thank you very much, Mr. Moderator. On behalf of the entire participants for these 3 days training by this great organization, I want to say a very big thank you for granting us this great opportunity. I tell you, it's a rare opportunity. I value what has happened for these 3 days because I'm in the field, and I know what this means to me and to all the participants. So on behalf of everyone, I want to say a very big thank you, and I wish you all the best. And we look forward for more of this because,
Yes.
like you will rightly know, this is more like a free. I know what it costs to get this training in other country, other companies, and so. But for giving us free, I think it's something we'll value, and we'll continue to partner with you by telling people. At least I have 2 or 3 or 4, 5 persons who joined this training through my link. I invited them, and the reports I'm getting from them or the feedback is quite awesome. So thank you very, very much, and we wish you all the best. God bless you.
Yeah, thank you very much, Mr. Wole Akinwumi. And for everyone, Ebari Abuwa, Eyodio, Echo, everyone, Francis, Jimba, Yakubu, thank you very much, everyone, for being a part. Yes, we are not disconnecting from each other. We are still going to be communicating via the WhatsApp platform. Every link, the assessment links will be dropped on the WhatsApp group. So please do well to do your assessment, attend to them, fill the certificate form, which is very important. And yes, endeavor try as much as possible, make effort to get the certification for this training. So till the next time we are going to meet, I want to say thank you and to wish you all a productive and a good, great week ahead. Okay, Mr. James. Mr. James.
All right, thank you so much. So let me just use this opportunity to invite you and to give you awareness that we have loads of more training this month. Okay, I will be on a training that's industrial electrical safety, advanced incident and accident investigation, which are very, very industrial. They have high industrial relevance. So please watch out for those trainings and register immediately. The link is dropped. Definitely the moderator will do the work of dropping those links with you. And all these your beautiful feedback, also let them be written. Go to our WhatsApp pages and then put those your feedbacks there. They are very, very important and we value them a lot. Let me also encourage you not to miss the first discounts. We understand definitely that the country is doing great. Let us be positive. So save your money by taking advantage of our first time deadline discount. It is very important. Thank you for appreciating us. Thank you for appreciating the moderator, myself, and the company. If you really have people that want to take this training, maybe as a group or company, yes, we normally partner with corporate bodies and also companies on these trainings. Yes, we can even come to do it physically with them. So if your company is actually interested, or you introduce it to your HR, will be done for us to come down for that training. Somebody was asking about practical demo and everything. Yeah, we do all that when we come physically, and then we have like some update class. So that's why it's good for you to subscribe on our YouTube channel, so that anytime you see update class on this or some demo, you can always be updated with it. Thank you so much, moderator. Thank you for giving me the opportunity.
Okay, thank you very much, Mr. James. Thank you very much, everyone. So do have a lovely weekend and a productive day ahead. Bye-bye, everyone. You can unmute your mics and tell me bye-bye, you. Thank you.
Bye-bye, sir.
Yes, sir.
Bye-bye. Thank you. Thank you. Thank you.
Bye, everyone.